Hey there, everybody, and welcome everyone to the latest webinar series with the Fluence and Inspire team. My name is Casey Rivero, and I'll be hosting today's event for you. So before we dive in, I would like to briefly review a few housekeeping items. So this webinar is being recorded and will be made available to you by next week. So stay tuned for a follow-up email, or if you want to follow us and the Inspire team on social media to receive notifications on when it's posted. So if you missed part one of our webinar series with Inspire, you can gain access to those recordings on our website. So in part one, we were focusing on new build planning and reviewed some basic terms and metrics related to lighting and HVACD. We also reviewed lighting metrics like PPF, PPFD, and DLI, as well as HVACD terminology like VPD and dehumidification. But today we're going to be switching the format a little bit. I would like to welcome our panelists, Robbie and Jesse from the Inspired Transpiration Solutions team, as well as Aaron from the Fluence team. So welcome, gentlemen. So I'm going to start this webinar off with two main discussion points before we dive into our case study. So in part one, we talked about metrics and terms regarding lighting and HVACD. I would like to now hear from you all on key concepts every grower and planner needs to keep in mind when retrofitting their facility. Aaron, from your experience in lighting, what are some of the key concepts that every grower should be keeping in mind when in their planning phase?
Thanks, Casey. Thanks for having me again, Fluence and everybody. Thanks for joining us, Inspire. Some of the key metrics, I would say light intensity is one of the absolute first things someone should look at whenever they're determining whether a retrofit is something that they should be looking into, and specifically its correlation to higher yield and whatever ratio that ends up being. One's technology as it relates to the tolerances that are required out of irrigation, fertigation systems, or different environmental control platforms, and able to meet the higher yields, or I'm sorry, higher light intensities that one would be using if you do start to look at retrofitting out of HPS. And then studies by people such as Dr. Bruce Bugby, or Leo Marcellus out of Wageningen, if you're trying to, let's see, correlate light intensity to higher yield amounts, I would say.
That's awesome. Thanks for that, Aaron. So Rob, Aaron mentioned one of the benefits of proper retrofit or expansion is higher yields. What impact does additional biomass and that higher yield component have on dehumidification?
I mean, biomass is a direct correlation to the amount of plant matter you have, which is stomatal, stomatal density inside of a volume. So the more stomata we have, the more pores we have into these wet caves that are the leaves, and that's more dehumidification that we need to handle. So there's all sorts of other different factors involved, lighting intensity and things like that, but for the most part, it's just a direct correlation. You want to get more yield, you're going to have more dehumidification that you need to handle.
Right, that totally makes sense. Thanks, Rob, for that. So when we're thinking about a retrofit, every grower will eventually evaluate not only the lighting and HVACD, but how these technologies work together to affect the entire ecosystem, right? They will be addressing. So what considerations do we need to consider here? Aaron, let's hear what you have to think on that.
I would say cubic space, cubic volume, room volume is something to be considerate of if you plan on going multi-tier. And that is one way that you could take a single level HPS environment and just automatically increase the output regardless of whatever PPF or tolerances your mechanical system has today. Just in theory, it could be upgraded. And so, there's two different ways you could do things. You can go up or you can go out. And in regards to a retrofit or an expansion, retrofit and then expansion, if that's the end goal. So yeah, I would say cubic volume, certainly. And then it's always, I think, incredibly important to be looking at analyzing light uniformity as you start to implement new technologies and capitalize on vertical space if that's the goal.
Yeah, Aaron, I totally hear what you're saying there. I think, going vertical really does allow you to maximize room utilization. It does create new things you have to think about, like new microclimates and appropriate airflow, and making sure that you have appropriately sized HVACD or dehumidification system. But ultimately, I sort of think it comes down to an analogy I like to make, that I feel like the cannabis market is sort of like a racetrack, and the facilities that we're building are like these race cars. And like Casey and everyone has pointed out, it really needs to be a fine-tuned machine. Everything needs to be functioning together. For years, we've been getting around the track with race cars and wobbly carts, but now the market is so much more competitive. It really does take a fundamental understanding of how you're going to use your space, how you're going to use all the mechanical devices in your space, and how you're going to get them all to work together to really maximize the yield and quality and quantity of that space.
Yeah, absolutely. That makes so much sense. In thinking and planning that every little step and every understanding of what you're trying to achieve is so important here, because every domino affects the next one down the line. So thank you all for that question. And as another reminder, if you're new to lighting and HVACD, there's tons of resources on both Fluence as well as Inspire's website that you can reference to learn a little bit more about the concepts like the 10 cardinal parameters of cannabis cultivation, as well as how to grow effectively with higher light intensities. So be sure to check out the resource sections on both Fluence as well as Inspire's page to update yourself a little bit more on the knowledge of what we're discussing here. So, okay, so now the second part of my question, why would someone retrofit, right? What's the purpose? What's the use of it? So I started with Aaron last time. So Rob, what do you hear in the field?
Okay, yeah. So we hear a lot of things. We got a lot of people coming to us and asking about retrofitting. From my perspective, whatever they say is right. So they've got a good understanding of their own local market pressures and all that other stuff. But if you want to pick one specifically, they're having a hard time with environmental control, and that's why they're talking to us, and the IPM challenges that come along with it. So if they're sick of that IPM spend every month being what it is, or not being able to hit their targets because of IPM challenges, I mean, that's a really good reason to retrofit.
Absolutely.
Yeah, I'd agree.
Aaron, what are your thoughts on why someone would want to retrofit?
Well, I guess intuitively, I would think that the reason to retrofit is to improve the capacity and production of an existing facility, and to make more money. And honestly, if you're not making more money out of if you're not getting money out of what you're putting into your business, in regards to capital, then I don't know why you're in business to begin with. But I think that there's a lot to be said for market shifts right now. Like, the price per pound of cannabis is fluctuating every day, and people are tracking it pretty diligently. But ultimately, once we're in a federally regulated market, we will start to see prices dropping. And so getting prepared for these things to occur early on, and adopting new technologies, whether that's HVAC systems or new lighting or new irrigation systems or control platforms. I mean, any of this stuff, any of these different technologies are ways in which you invest into your business in preparing for an upcoming market, either regulatory shift or, market shift that moves the price per pound up or down. It's not probably going to go up, but down, and then maybe back up. So at the end of the day, I'd say money drives all decisions in regards to what you put into your business, whether you're a pizza joint or a 20,000 square foot grow facility.
Right. And I mean, I think we kind of see a reoccurring theme here and throughout the presentation of the fact that if it doesn't make dollars, then it doesn't make sense. Is it a hobby of ours, or are we trying to make a business out of it? And so realizing that is very important. Thanks for that, Aaron. Jesse, what do you feel about this?
Yeah, I mean, I'm in the same boat with you guys. It's about making money, but having run commercial cultivation facilities, for me, it sort of boils down to four things: quantity, quality, consistency, and efficiency. And if we can maximize all those things, we are going to make money. We're going to have a sustainable, successful business. And something I always like to bring up to people is, really trying to figure out what a gram is worth at your facility. And there's different factors and there's all kinds of variables involved in that, but you can hold some things steady. And really, if you think about a 2,000 square foot canopy and a price per pound of $1,400, if you can increase 1 gram per square foot over the course of that facility, annualized, it's going to be $30,000 plus in income. Now, if you're at $2,800, it's going to be closer to $70,000 per gram per square foot increase you can do. And that applies to quality and efficiency as well. These little incremental steps, when you really pencil them out, you make some decisions a lot easier when you think about achieving your goals and you're doing it calculating, okay, well, this many more grams per square foot is going to equal this many more millions of dollars for our facility each year. And that's a worthwhile calculation to do.
Absolutely. And those benefits are really important to understand the potentials of when you're, deciding your business plan or how to scale or how to move forward from there. And a couple other things for considerations too is there's always pitfalls and there's always limitations. Every property, every state, every zone, there's always limitations depending on that. And really understanding and knowing those limitations beforehand really will help, in the permitting, the planning, the HVACD, the lighting, understanding what your limitations are as far as your company, as well as the property that you're putting your business in are really important. Power limitations, state regulations, incentives that you can possibly gain, permitting issues. So it's really good to understand what your limitations could be, because that really helps understand the timeline as well too. So let's pop back into the presentation here. Perfect. So what we're going to do today is, like I said, we're going to talk about a specific case study to kind of bring reality into what we're talking about for you guys. And this specific case study goes by, essentially gives it's an overview of what decisions they had when they made the choice for their upgrade and what type of upgrade they made. So with that, reminder, to submit questions in the below Q&A section so we can address them after the case study review. So if you guys have any questions about what we've gone on so far or what we're covering through the rest of the process, be sure to check the Q&A section below. Ask us any questions and we'll address those questions slightly later. So Jesse, will you set the stage and describe our featured customer, Clarity Gardens, in this case study example?
Absolutely. We've been working with Clarity for a while now, and Clarity Gardens is a commercial cultivation facility in Denver, Colorado, as you see, and it's being run by Lance Savage and a team out there that work really hard to improve. And basically, we like to tell the story of how it started. And initially, Clarity Gardens was a single-tier HID, conventional, non-integrated, platform for cultivation. And we came in and did an assessment with Lance, and sort of what we realized was low light conditions, lack of appropriate airflow, undersized dehumidification, all really led to a lack of control. And that lack of control led to swings in temperature and humidity set points, lights on, lights off, transition, which then led to IPM vectors, expensive IPM vectors that needed to be consistently treated, which increased the price per pound. But even more so, it also caused failed tests. It caused degradation of product. Their inability to control VPD meant that they were compromising their yield and weren't able to get the most out of their genetics. And realistically, it boiled down to Clarity saying, all right, if we continue along this line, we are not going to have a business anymore. And we need to seriously assess our goals and our capabilities and how we're going to get there. And that's when we really started thinking about a serious retrofit for Clarity and which direction we should go.
Right, that's awesome. Yeah, thanks, Jesse. Okay, so we're saying with any retrofit, there are many questions you need to work through with your lighting as well as your HVACD partners. So let's review the paths that they could take, as well as reviewing the advantages and limitations for each decision. So essentially the first direction that we're going to kind of speak of is moving from to an LED facility. And one path someone could take by moving from HID to a replacement, a one-to-one replacement with LED. There are two strategies you can deploy here. So essentially you can either work on a PPFD match or a PPF match, the amount of photons that one fixture puts out compared to the same amount of photons or a similar amount of photons another fixture puts out, as well as a wattage match. If X amount of wattage goes into creating one scenario, we'll match that with the same X amount of wattage to meet the next scenario. So as you can see, our first scenario is the HID to LED. PPF match to wattage match. So the next scenario that we have is HID to an LED multi-tier setup, right? Or the opportunity to go from HID directly to LED multi-tier is another option. So here you will run into limitations with the amount of investment as well as timeline and planning that it takes to successfully execute this upgrade, right? We see two options here on the right. We see a wattage match as well as an additional square foot of canopy. And those are the main key points to moving from an HID system to an LED multi-tiered system. So let's see. Every grower is always thinking about these two very important decisions. First decision is essentially, will I be able to yield the same or even improve on my yield, right? And the second question or consideration with the potential outcomes. This is something that is should be a question going through our minds continually when we're discussing a retrofit with our partners. It is a way to understand how effective your system is comparatively to other systems around the country. The power score is one way to do that. So essentially putting your information as far as your electricity consumption into the power score will help kind of give you a benchmark on how sustainable and how optimized you are compared to other facilities of the same type of size. So operational efficiency is really helpful with this power score. And so that was one reason why I kind of brought this to the attention, is because there are ways to understand how effective and how optimized your farm is comparatively to other farms of the same type. So the design section, let's take a look at the HID to LED component of this. And for this portion, I'm gonna go off of my video because the screen is kind of lacking a little bit. Okay, hopefully this helps make things faster. So Aaron, we're talking about a PPF match. Can you kind of help dive us in a little bit more on what that looks like as far as our planning and what we're going to expect as far as a PPF match situation?
Sure, thanks, Casey. So, all right, I guess I'll take a brief pause and hit a couple of key points going back to one of the first things I said in the webinar, which is the drivers that are impacting what we see as a payback period. And that's a period in which you invest in a new technology, and that technology then makes enough money that it made sense for you financially to put that investment into your business. That's something that at least I look at on a daily basis with anyone who will let me run analysis with them and assist them in making informed purchases. So when I say payback period, I just want everyone to know there's a lot of things that go into payback periods. We're, in this sense, we're strictly talking about the things within the cultivation portion of the facility, i.e. the things that drive photosynthesis, drive yield and or change quality, and therefore are seen as indicators as to like how quickly you can pay back against whatever you were doing before, and that would be considered your baseline. So just laying that foundation, and going back to the idea that more light equals more yield, or less light equals less yield to some degree, that along with operating expenditures, the savings thereof or not, depending on what you're doing, are the factors that we're looking at on a daily basis at Fluence. That we're trying to help our partners, our clients, make these informed decisions, business decisions based on their own baselines and where we think we could get them. So to start, there's two options to go with here on a single level, we'll say. One in which you can take your HID and match it, the full room PPF, photosynthetic photon flux, not PPFD, and consider that as a driving factor in what you can obtain through yield gains and whatnot. And then you have the electrical savings, right? And so this first scenario, we're actually taking the same PPF, room flux, and we're just replacing, in our case, for Fluence, a 1-to-1, because we have a 1-to-1 replacement for double-ended 1,000 watt HPF. In this sense, we've saved 40% in our energy usage within the room. There are things to be considerate of from an HVAC perspective that will be considered in the, let's say, the analysis, the payback analysis, whenever you were to do something like this. Maybe your system just isn't handled for that reduction in load, and Rob can probably speak to this a lot more eloquently than I can, of course. But someone told me one time, you'll never save your way to prosperity, and that stuck with me. Because one thinks that, if I start paying less for energy, that I'll eventually be able to, become more prosperous. But in reality, the value of cannabis being what it is, that's your driver. Your revenue drives everything. And so, although I can see there being a reason a certain set of reasons for someone doing a 1-to-1 swap out and saving that energy, specifically if you're trying to phase out or phase up, but it's not always the most economical in the short term. Maybe it's economical, maybe in the long term. And the timeline in this sense would, in my case, if I was the buyer, be focused on rebates, cost of energy, bulb changes, a lot of the operating expenditure gains that maybe you're just dragging your business down. And maybe you have an investment that allow you to upgrade, and then over the course of a few years, you'll maybe 2 or 3 years, you'll recoup and then be more prosperous in the total cost of ownership. We can go to the next slide. And I'll be quick. And so, in this sense, we've taken a watt-to-watt match. And what that means is for every watt that I would be using in an HID space, I'm now able to drive more light intensity and therefore photosynthesis within that room. Right here, we're seeing an 888 micromole per meter squared per second to 1453 micromole per meter squared per second average. It's a huge change in the amount of photosynthesis that could occur in that room if your genetics were optimized to take it. So things to be considerate of, although there are potentially very quick paybacks here, other technologies tend to be limiting factors. Your environment could be a limiting factor. If you're hand watering, you're not going to get up to 1400, just not going to happen. So in this sense, R&D is very important. Genetics are very important, and being able to take that light intensity and harness it, given all the other parameters, environmental and technological, that you have and are limited to. Rob, you want to go to the next, I think, is your slide. Awesome.
Missing one. Well, the one thing I'd like to bring up immediately is HID to LED. The change in set point alone is going to get you more capacity out of your equipment. And what we're showing here is just a standalone system run at 2 separate conditions. The first condition is at standard HID, 75 Fahrenheit when the lights are on, 50% relative humidity. This seems to be an ask from a lot of the people we work with. And you can see what the unit capacity is in terms of the peak pounds per hour of moisture removal or dehumidification capacity. Well, the immediate jump to an LED system, which doesn't have as much forward throw infrared, you're going to want to keep the room temperature up to maintain and maximize that optimum zone of leaf temperature for plant productivity. You're going to get that extra 20% out of your equipment. So if you're going to do a PPF match, then what you're going to end up with is probably not having to do anything to your HVAC equipment, especially if it was on the edge before with HID. You're going to be able to probably take care of the extra load that comes along with LED. If you're doing a wattage match, I would say that your transpiration rate is going to go up at least 20 to 30%. Can we go to the next slide, please? So your transpiration rate is going to go up at least 20 to 30%. It might go up even more. This comes down to the efficiency of the grower and the capacity of the grower. You're going to want to think about, despite all of the extra capacity you get, how you're going to supplement. I don't think there's a need to scrap and start fresh. Maybe there is. Maybe you just don't have the physical space for it because the equipment would impede on the growing room itself. So you're going to want to keep that in mind. If you were short before, you're definitely going to be short after. A wattage match is going to end up in a situation where you are still lacking capacity because the intensity of the lights is increased. You're going to get so much more biomass inside that room than you would if it was just a PPF match. Okay, so I'm going to zip through 3 different scenarios here in terms of a CFD analysis we've done on rooms, and this is typical of what we're asked to do in a retrofit scenario. And what we see here is a room as it stands. The red boxes are dehumidifiers sitting up inside the space. The gray boxes up above the green canopy, those are the HID lights. And we have the return and supply. And this is typical. Rooms used to be designed, and sometimes still are, designed with supply being shot out and spread over top the entire canopy, and then the airflow is supplemented with wall fans and other things like that. Let's go to the next slide, please. This type of space with the overhead airflow delivery, which is just, typical, this is how we did it, and this is the room we're dealing with, it's going to give you hot spots. It's going to give you fast and slow spots with your airflow. You're going to end up with pockets of IPM vectors, pest vectors that are going to cause a problem inside the room. It just takes one spot for them to proliferate, and then you've got them all over the space. Despite the best intentions of, high efficiency filtration, things like that. It's in the room, it'll be in the room. You have to manage it with personnel and labor and IPM strategy. It's not ideal. So one of the things that we consider when we do a retrofit is thinking about what are the small things we could do? What changes can we affect inside the room without making too much of a mess so that we can better get airflow through the space? Airflow is king in these spaces. If you go watch the 10 cardinal parameters, you'll understand how important that is to us. We stress it every time we talk about these rooms. So let's go to the next slide. And this is a scenario where we've converted the supply and the return. So we are dumping the supply into one end of the room, and we've got the return across the entire space. Now, I've shown here in-rack airflow tubes. We have them turned off for the next slide. Let's go to that. That simple reversal of the duct gets some much more even temperature and airflow distribution across the space. Now, it might look good from a temperature perspective. What we do see are some dead spots, though. If you look at the vectors, the velocity vectors of the air in the left and bottom diagram, you'll see that the arrows are everywhere. And where there's ridges and where there's arrows coming together, those are dead spots of airflow. That is going to become a problem from a humidity perspective. So let's say we do the reversal of the airflow inside the room, which is a pretty minor adjustment. And then we take fairly low cost in-rack airflow tubes and apply them. Next slide. The change is monumental. So from a temperature perspective, up on the top right, we can see that the temperature is very even across the board. But the demonstration of the vectors here is so important to us to understand that we get almost 90 to 95% of the air getting up and out of the canopy as quick as possible. It makes a huge difference, and these are very minor changes, and definitely something you need to consider for a retrofit application. Whether you're having to buy more equipment or not, PPF match or wattage match, both these things need to be considered. Next slide. So that's it. Who's back to now? Is it Casey?
Awesome. Thank you, Rob, for that. I mean, it just goes to show that, planning is paramount when figuring this out, because dealing with dead spots, dealing with poor temperature fluctuations throughout the canopy brings us just myriads of issues, as Jesse and Rob both tells us. So, that planning is so important in being able to consistently do that. So Aaron, okay, so let's take a look at the HID to multi-tier model. As we're saying here that we're showing, you can either, achieve this through a wattage match or additional square foot.
Thanks, Casey. All right, so this is an interesting scenario, and one in which I've probably never seen or I've never proposed it to anyone. And this is, what if I were to take the specific number of watts and then spread them out over more area, so to speak, to better fit into whatever mechanical infrastructure and tolerances are installed. Essentially keeping roughly maybe the same total, the same PPFD, so to speak, but then leveraging your micromole per joule being much higher and taking that and spreading it over more canopy. Maybe you see, in this case, 800 micromoles per meter squared per second as being, the sweet spot for wherever you are at, whether that's your ability to regulate higher PPFD or your genetics tend to like it, whatever it is. This would be an option in which you could take, the sensible load or the wattage requirements of that space, and then just, use that to grow more canopy at that same or similar level. Although it offers probably a minimal impact to all the tolerances regarding electrical and sensible load and whatnot, there would be an increased plant count in this scenario to the degree of, tripling, right? And so I'm sure Rob in this case would say, well, your need for water removal is going to go up exponentially. And so that's something that would add probably to the cost of this, not even talking about the cost of the benching and everything else that would be needed to get there. I always think about air movement as it relates to breaking plant boundary layer, to regulating the leaf and ambient temperatures the way you need it to. There's all these infrastructure costs associated with doing these different maneuvers, and they change ever so slightly depending on what you're trying to accomplish or what you would like to accomplish given your limitations. And so this would be something that you could consider. In this case, it's a 3-tier pallet rack scenario. We can go ahead and go to the next slide. Fourth option is a complete disregard for any type of wattage restrictions, probably a disregard for capital restrictions in some capacity. Just it's total optimization, right? So take what you've done with your HPS, whether it was, it was doing okay for you or it just didn't work, whatever it might have been, the reason for the upgrade or retrofit. This would be maxing out your potential space. You're adding more light intensity, you're using slightly more wattage, although that differential isn't that great. And so it's a benefit to you ultimately if you do or can use any of the mechanical equipment that was installed to begin with. But your production goes through the roof if you're able to increase both canopy and light and drive higher photosynthesis through higher light intensity. So long as everything is optimized environmentally, this would be the true optimization of a facility. And if space is something that's hard to come by for you, or your license doesn't maybe match your building. Say you've got a 20K license and a 10,000 square foot building. Well, there's some optimization to be had, right? Because that's just a limitation that everybody should be striving to overcome. So yeah, I think that the payback on something like this is very quick. The capital expenditure is very high. And I would say that R&D, going back to it, R&D in multi-level systems, R&D with new technologies like LED or new HVAC systems, along with your genetics and their potential to optimize with you and your technology, is going to be limiting factors that you should focus on, hone in, and then, that's where you can really invest your time and your money and your energy to improve your business's financial performance for years and years. Rob?
Yeah, you couldn't have said it better. I mean, R&D is the king. If someone is going to go to a triple tier system and they've never used that lighting technology before and they're bringing in new genetics, it's going to be almost impossible to predict how much HVACD they need. It's an interesting task whenever we go back and we look at the rooms that we've been asked to design. This is a bin data graph indicating a particular facility, their flowering room, and what their gallon per square foot of transpiration rate is. And we are tasked with designing the HVACD system for it. Now, I'm going to leave it to you to figure out which of the 4 tags around the outside matches which bin. But this is a conglomeration of all of them, and it's all over the place. The fact is, if you're not doing that research, if you're not doing that ahead of time, figuring things out, you can end up in trouble. And this is why I think a lot of these retrofits to multi-tier, they are served well by phasing, really. To jump in and say, well, we're just going to go hog wild and double our canopy across this entire facility, you're missing all the lessons that you learn in the first phase when you do one and you say, oh boy, this is what we learned. And let's not carry those mistakes forward. So I think that's absolutely very important. This is, research is key, absolutely. But Jesse, you've been in these facilities. You tell me what are your takeaways here when going to multi-tier?
I just think that, multi-tiers, it's a little bit different ball of wax. You have to think about, like Aaron said, your genetics, your cultivation style, and the other things that have to transition as well. So, just like we've been talking about, all these things sort of roll together. If you were a traditional 6-foot plant HID cultivator with disregard for cubic footage in the space, you're going to have to make some changes and some transitions to get into an effective multi-tier cultivation operation. So yeah, I think it's important to take a look at the metadata to understand what other people are doing successfully at cultivation facilities of scale, and also just what's actually going to work for you. What can you actually achieve? What are you going to be able to fulfill? What's your vegetative space? Are you going to be able to fill in a multi-tiered LED? Are you going to have to expand the vegetative space? Lots to think about.
Awesome, Jesse. Yeah, absolutely. Good call on that. There is a lot to think about, and in combining what you and Rob and Aaron have said, the planning is so crucial for the success moving forward, and what you're actually capable of achieving is based on how much planning and preparation you've been through. So so now that we've seen the different paths that were available to Clarity Gardens, let's just review the decisions and the payback of what that looks like from the decisions that they made. And I'm going to briefly kind of go through the financial performance because, numbers are really significant to each situation, each farm. But this financial performance scenario just kind of goes to show of the increase of production and revenue that is, that you can attain based on these efficiencies and these upgrades. So reviewing the payback and weighing the improved performance results, they actually chose moving from HID to an LED multi-tier system. And these are the efficiencies that Jesse has been explaining to us and Rob has been explaining to us, moving from the single tiered HID systems to the multi-tiered LED systems. So let's kind of quickly walk through the numbers. As you see on the left, their original values, as well as far as the canopy, the grams per square foot of production, the price per pound of their dried flower, and the revenue and profit margins. As you can see, originally gaining $1,200 per pound at 40 grams per square foot with an operating cost of $755. So now as they were able to phase into these new efficient ways of production, right, you can see their increases are exponential, right, through their Bloom 3 and 4 upgrade to the Bloom 1 and 2 upgrade to now with the full canopy of their full bloom set, which is about 13,000 square feet of bloom canopy alone. you can see their delta is quite favorable here, going from 40 grams per square foot to over 60 grams per square foot, a price per pound of flower starting at around $1,200 per pound and going up, minimally of $1,800 if more, as well as something that I want to show you guys, which is a very important part of the financial performance, which is the operating cost per pound of flower. We started out at a $755 pound to produce, and moving through these efficiencies, it's given us the ability to minimize that to a $271 pound cost per pound of flower, which is an amazing component to that additional revenue per year. And so, the caveat that I do want to explain is that every upgrade, every facility really depends on genetics, depends on policies and procedures, and depends on how much planning you have and research you have to be able to move forward within that success. So with that financial performance, we're going to go through a couple key takeaways. And before we enter into the open Q&A, I would like to ask each of you to highlight, let's say, 1 or 2 key takeaways you have for our audience. So let's maybe start with Aaron.
Yeah. So key takeaways. Let's see. Define your baseline. What are you cultivating under today? How is it working for you? What's your end goal? What do you want to be doing in 5 years? Do you even want to own a cannabis business in 5 years? Define your limitations, and then start to make some correlations between light intensity and yield assumptions, conservative more than likely. And then just look at, how can I invest in my business? Is it worth investing in? And what are key ways that I could, invest that capital into different technologies that'll ultimately serve me very well?
That's a good one.
Yeah, Rob, what are your thoughts?
Yeah, I want to just highlight that one of the most important things you can do is bring controls to the table first. You can do this before you upgrade the facility. If you want to know what your facility is doing, start with controls. Are you going to do VPD control based on a chart on the wall? Or are you going to monitor the actual canopy temperature with cameras and understand what that means and understand what you're doing and how much better it's going to be, how much more transpiration you're going to need because you've got a higher VPD, or how much transpiration you'll have to handle with dehumidifiers or dehumidification, HVACD, because you have a higher VPD. So all of that is important, and it'll help you plan for the future. It's that testing you could do today as you build out into the future.
That's a really good point, Rob. I like the concept of controls because it leads to the collection of data. And I feel like that collection of data gives you a real action plan. And, for me, it always comes down to quality, quantity, consistency, and efficiency. And if you're going to create an action plan to refine those and improve those, you're really going to need to have data to know where the weak points are and to know where the points that you can improve upon are. So yeah, collect the data. Absolutely. And then use it and take action,
Amen.
Yep. Information is paramount in understanding how to move forward and how to move forward effectively and efficiently. So absolutely. So before we dive into all these great questions that we're seeing pop up, there's been a couple questions about modeling. So Aaron, what type of software or how could someone use the lighting designs that you've presented?
Thanks, Casey. So yeah, am I on mute? No, I am not on mute. Okay, sorry about that. We at Fluence, we use Dialux. It's a very simple program. It is freeware actually, so anyone can download it. We use the first or previous iteration. They've now updated their software to Evo. And we like Dialux because it's easy. If you're talking about horticulture, you don't need to model full buildings, right? We're able to use CAD and everything else for really detailed electrical and installation instructions. But for us, the need to define, the conversion between PPF and PPFD and the coefficient of utilization, that converts them. It's the simplest thing that we can do. And there's a ton out there. I would say AGI 32 is a very common one. Autolux, Relux, Trace Pro, Focus Track. There's Calculux. There's a ton of them out there. All of them are, basically built for commercial lighting or industrial lighting, and then most are just appropriated for horticulture outside of a couple. But we keep it simple and use a KISS method for lighting design.
All right. So it seems like the takeaway from that is to really work with us and work with Fluence and work with the team
Absolutely.
to understand how that lighting design is being developed.
Perfect. Great point, Casey. And I'll just touch briefly on that. We actually do offer, services. If you want to see a room designed, you reach out to us. We'd be happy to do it, live, so to speak. If you want to see how it works or whatnot, just contact us. We'd be happy to drive you through that whole process. It's super interesting.
Right. So Rob, how about you? How are the rooms actually being modeled? Are there standard models, or do you customize each model for every new project type?
Well, we get an intuitive sense from some of the standard models we've done, but as a service, because we really want to be 100% sure that your investment money is going in the right direction, we basically model every room. Off the cuff, we can make decisions, but once we're invested with a partner, and we're going to market with them, and we're going to help them get the best out of their rooms, we are absolutely modeling every last room. And there is no KISS principle for canopy airflow. And the amount of research we've done and the data heavy modeling and remodeling and working with a manufacturer that we're partnered with for the software, it is intense. It's not easy. I think that any one of the modeling tools out there, Simulink or SimiFlows rather, and Autodesk CFD and SolidWorks, I think a lot of them have the ability. It is the difference between having the ability and taking all the papers and the research and applying it to a canopy model. That's the hardest part of this whole thing. That's what we do for everybody. We use that canopy model that we've developed and apply it quickly into CFD models of specific rooms.
Awesome. Great. So yes, everything is absolutely customized to exactly what yours. So now let's spend some time talking through these lighting questions, and then from there we can move on to the HVACD portion of the questions, and then bring it home with some facility questions. So Aaron, can you discuss the correlation between light intensity and introducing CO2 into the environment?
Absolutely. I was on mute. I couldn't wait to do this again. So using visual references is always good. I'm a visual learner myself. So this is backwards, unfortunately, but it is a graph that shows photosynthetic rate plus light intensity. What you see is a lower supplementation on the bottom. This is referencing a low supplementation or no supplementation of CO2. And the higher we go in light intensity, obviously that line, the more critical it becomes to use CO2. For cannabis, there's a debate whether 1,200 or 1,500 is probably the right number. Regardless of the rightness of that and the financial implications of that question, everyone should be optimizing using CO2 if they can. I come from a long background of closet growing, and so I know that there's situations in which you just have to use ambient air. Then the question becomes, do you increase light intensity, or and do you take a point of diminishing returns? That's a good question for everyone in the hobbyist market to ask themselves. If you're a commercial grower not using CO2, you're crazy. That'd be absolutely wild. But yeah, it's there, and if you want to utilize over 500 micromoles per meter squared per second average, you should absolutely be supplementing CO2 in bloom.
And
Awesome.
can I add to that real quick too, Aaron? I just want to say,
Jesse.
I love what you're saying. I think it's important too to think about the delivery of CO2, not just to the envelope and to the room, but actually to the plant, and making sure that we're delivering to the stomata. I've been in so many facilities where I've come in and I've measured 1,200 ppm somewhere in the room, but not near the canopy or not underneath the canopy or not directly around the stomata where it's going to be absorbed. So I think it's important to think about in-rack airflow or some sort of delivery system that gets that CO2 that you're paying for directly to the plant where it's going to be absorbed, rather than just trying to rain it into a room and hope for the best.
No, that's a great point. Consistency in measurement and consistency in deployment is so key. Absolutely. So HVACD focused, how do you guys collect the data for transpiration rates across the grow room? And it's kind of a three-part question. How do you measure the airflow in the different parts of the air or different parts of the room? And then kind of more technical, what wind speed is ideal for air movement and for circulation?
Yeah, man, one sec. Yeah, great questions, all of them. How do we measure transpiration rates? There's a number of different ways you can do it. The best thing you can do is a transpiration test. So if you're in a room that is operating and you can run a transpiration test, it's basically measuring the amount of water into the root zone that doesn't spill off, that ends up leaving the root zone, the weight of the plant, over the course of 24 hours during whatever part of the cycle it's in. So there are transpiration tests that you can research and that are used in research in academia that would probably serve you well. We use a close approximation using sensors inside the room and inside the HVACD equipment we supply. This is a big challenge because sensors stink in the commercial world. So if you're using just off-the-shelf sensors, you're going to run into problems, almost guaranteed. The drift is too much. 2 or 3% on a temperature or humidity can throw off an entire transpiration equation. So there's a number of different ways to do it. It's an investment in your facility to put those sensors in and get a good approximation. And we've been very close with ours. We've got, within 5%, and that's as best as we can hope for in the rooms that we're working in. How do we measure the airflow in different parts of the room? Man, that's a tough one. We are putting the models to the test in certain facilities. We understand the hole density we need and the velocities out of the holes in the tubes that we supply to get the right velocity in general at the canopy level. What is the ideal? I don't know. I don't have an answer to that. What we're shooting for is about 1 meter per second. I think different indications from different strains that will maybe require more or less. The fact is, facilities change over time, and we're shooting for a good approximation into the canopy just to break up any of those microclimates and also break through the boundary layer. We're bringing CO2 through the boundary layer into where the stomata are sitting. So we want to do our best to get fresh stomata in there, that cool, dry or warm, dry air up into that stomata and induce transpiration. I don't know if that answers the questions, but I sure do hope we went down the right path.
Well, I think in a lot of ways it comes back down to data and measurement. And, I think there are some things we know and then some things that we're measuring to get as close as we can. Like we know the plant's going to take up X amount of moisture every day. And we know that she's going to transpire 95 to 97% of that moisture that she consumes over a 24-hour period. We know that a significant amount of that transpiration occurs when the lights are on, somewhere between 70 and 75% in a flower room, maybe a little bit more in a veg room. And that's sort of one way that we break down how much moisture is going to be going into the space and going into the air. And think about, canopy, cubic footage, and, media choice and watering rates and things like that.
Good point.
Awesome, you guys.
I'll just throw in there one last thing. From a controls perspective, we feed that data back to the customer into the facilities every single day. So they're watching their transpiration rates. If something goes wrong, if the transpiration rates are low one day or they're too high one day, they're going to know there's a problem inside the room. It's just another metric. It's another alarm we can set if we think there's a real problem that we can handle ahead of time.
Right. Absolutely. Good call. So we have another question from an attendee asking, so transpiration rates go up 20 to 25% in a wattage match. What happens actually in a PPF match with the transpiration rate?
Basically, these are all approximations, but in a PPF match, nothing. If we've got the room temperatures at the right spot, the VPDs in the right, so the room humidity is in the right spot as well to maintain the VPD that's ideal for that plant in that cycle of its life, then the amount of photons causing photosynthesis we're gonna get there the same ppf from one room to another, the same amount of transpiration. Will it be easier to handle? Yes. LED, temperature's warmer, and the dew point associated with it is higher. It's easier for moisture to get pulled out by the same equipment that was there in an HID facility with the same ppf. And was there another part?
So what you're saying is it's actually based on plant performance, not just nameplate information from equipment in the room.
Yes, that's right.
Yeah, very, very, very good. That's something that seems to be lacked quite a bit in planning. It's there's no information about the plant's performance. It's all about how many watts per lights, how many watts per fans, and this and that. But we're not actually even looking at plant performance in those values. So,
and the 20 to 30 number was like on the low end. I think what we'd see on a wattage match is higher, but we're going to start with 20 to 30% more, which basically eats up all of that extra capacity you had if it was right sized in the first place, and it might not be. So everything requires study and understanding, and you should really invest in the controls ahead of time to figure out what your room is doing now before you go and upgrade it.
Right, have that baseline. Start it out with as much knowledge as possible. So as we approach the hour, I want to thank everyone for your attendance. Because we have so many questions coming in, we're actually going to extend the session for another 15 minutes. So for those of you who need to leave, no worries. I won't be offended, don't worry. But this session will be recorded, and we'll send you a link early next week. Also keep checking back on the Inspire page as well as the Fluence page for updates on that. So now we're going to move to the customer questions, the customer questions. Let's talk market and how to leverage your retrofit to market changes. So we have a question that asks how to forecast the market in 3 to 5 years based on access to current information. I would like to make a slight change to this and talk about how that is affected in local markets as well as genetics.
There's this one too, Casey. I think we could all answer.
Yeah, I think this is how to exactly.
All four of us could answer in 4 different ways here. So, I don't know if we want to be brief and all go through it. And, what do you guys, Rob, you want to start? What do you see the market doing in 3 to 5 years? And how do you tell people to plan?
I have no idea. I care about compressors. No. I look, I'm not a cultivator. We have people that work with us that are, and we hear from them. I would say that whenever we go to a market, the question is, how far along the Denver path is it? Right?
Yeah.
So, is it about to blow up because the same set of regulations caused Denver to expand and contract? And so what if a market's different and they have better regulation? How's that going to change? Have they been able to keep price per pound up and keep the value of the product up? These things need to be taken into account. I do not have the finesse or understanding of the markets in general. And that's why we work so closely with the people who are doing it when their hands are in the dirt, including Jesse, right? I mean, Jesse, you're going to put so much more color on this, on my ignorance here.
I mean, I feel like, who knows, right? It's a crystal ball approach, but we've definitely seen some markets develop and mature, and we've seen what happens. And the truth is that really good cannabis is always going to sell. Really good cannabis is always going to extract better and make you more money. So you have to think about what's happening is that more and more people are learning to grow really good cannabis. More and more people are producing more really good cannabis. Now, are they doing it consistently? And how efficiently are they doing it? What's their cost to produce a pound? So you really have to fine tune those variables and to stay competitive. But the truth is everyone that I've seen be able to fine tune those variables has been competitive. When the market compresses and the price point goes down, they're still efficient. They're still getting top tier pricing relative to that market. So to me, it's a little bit about cash flow and brand recognition through that consistency. But maintaining the capital flow is through really being able to do it cost effectively without missing a beat. And if you can produce really good weed, you'll always sell it. It might not be at the number you want, but it'll be relative to the number of the local market.
Well, that's what happened at Clarity. That's the case study right there, right? They were able to actually increase their price per pound, right? Bringing new genetics in the rooms that they could almost double the dehumidification rate, and as they double the tiers, their VPD control is spot on, which means they can simulate the stresses and the strains and the conditions that those strains really thrive in, and gets them to the top.
I think you nailed it, Rob. Like, I was just recently speaking with Lance about, the ability that the multi-tiered LED integrated HVACD system is allowing him to grow new exotic genetics. And as a result, he's getting out of a certain pinch point and getting into a much more competitive space where, you might see high grade compression at $2,400 a pound for the best possible product in Colorado. And he's able to get more than that because the product is consistent. It's wonderful. It's special. It's cured. The test results back it up.
Right.
And we can do that. People clamor for your brand.
Yeah, that's right.
Right. And so essentially what I'm kind of hearing is you can only do so much forecasting within the market. It's really about evaluating what you have and your goals within and seeing how to most efficiently optimize what you have. That way you're always on top of what the market does, as far as cost for production, amount being produced per square foot. Optimizing will help prepare for wherever that scenario goes within the market. Seems to be what I'm hearing from you guys, right?
Yeah.
Great. So to the team, how and when do you address the building envelope in a retrofit? We see a lot of growers trying to retrofit a leaky warehouse or barn or some type of structure that drastically affects the HVACD sizing. How do you address this?
I don't know that it actually affects the HVAC sizing all that much if you do your room construction right. So the majority of facilities that we're in, if it's going to retrofit a leaky barn or warehouse, what we're going to find is you want to spend as little money on the envelope as possible. Pump as much heat into it in the winter as you can to keep it just around room temperature. And use insulated metal panels or some sort of insulated panel to maintain a sealed and well-insulated environment. Inside that grow room, it's going to be whatever the grow room wants to be 24/7, 365. So if I'm using really thick, 6-inch insulated panels all the way around and I've got a concrete floor, well, if the concrete around that room is at 65, 68 degrees, there's an efficiency loss if you don't patch up the holes in the ceiling. But that efficiency loss is paid back by the quality and consistency of what's going on inside that room. So precision temperature and humidity control inside the barn area, not too worried about it. Odor control, sure. I'm doing my odor control right. I got to make sure that I'm a good neighbor. I might have a lot line issue I want to deal with, and not have the people's come in and
Leaky sounds like an IPM issue. Leaky just like screams IPM problem to me.
Mm-hmm. But that's the outside of the building, right? So
even outside, if your outside's not clean, your inside, it's going to be hard to get your inside clean. So but that's outside the realm of lighting and HVAC. It's just cleanliness in general. But leaky is not good. You get a little puddle from the roof that sits there for a couple of days and develops pythium, and then everyone just sort of walks through it and goes right into the facility. Yeah, fair. Leaky's not good.
Right. And so kind of to piggyback on that question, do you guys ever consider the possibility of exchanging air from within the exterior or with the exterior in order to minimize HVACD consumption when you're in a good climate? Sounds leaky.
That sounds leaky.
Sounds leaky.
Leaky air, maybe. I don't know.
So basically using air exchanges
outside air.
Or use exactly.
Outside air.
Yeah.
Yep.
Well, this is all part of it. So one of the reasons I'm not so worried about the air quality in my warehouse space versus in the room is because I'm usually pressurizing my room. I'm pushing air out of it. That air is clean. It has been sanitized. The outside air I bring in to pressurize it is clean and sanitized. And then I'm pressurizing the warehouse relative to the outside. So it's a chain of pressure. So I don't have things just kind of leaking in willy-nilly. Now, you're right, Jesse. Water leaking from a roof, puddle sitting on the floor, huge problem, right? But in terms of air quality, if I've got the pressure chain right, and I've got the filtration done right, then I can do a pretty good job of keeping that air from the warehouse seeping into the room. and I can keep that air pretty clean as well.
Right. And you know that's the appropriate dose of CO2 relative to just trying to bring in outside air and have to make up the CO2 that you purge in that process, and just controlling it and cycling it through gives you more economic efficiency.
Yeah, that's right. You want to bring in as much outside air at 400 parts per million more
Right.
as you can, and just keep that 1,200 to 1,500 parts per million inside the room where the lights and the plants can take advantage of it.
Right. And then also it kind of depends on local ordinances and zoning rules on whether you have to use economizers and things like that, you know, to get around those type of things. Probably just depends on where you're trying to build, I'm sure.
You know, I would be surprised if there's a requirement for economizers, because it's just such a unnatural thing to do in a facility.
Mm-hmm.
If you know that you need this much CO2, you're basically going to be burning through CO2 as the air goes once through the room. And we're doing 20 to 30 air changes an hour here. So every 2-3 minutes, we're changing the air in the room. we'd be throwing in so much CO2 into that space, and economizer almost becomes infeasible, is the numbers that we've found.
Yeah, absolutely. So when looking at all the costs associated with an expansion or a retrofit, this is kind of a left field scenario, you guys. Have you seen any scenario or any projects where the grower has actually been able to quantify the employee workload or labor amounts that are reduced associated with retrofits? I know we see retrofits as far as power, consumption, this and that, but have we been able to quantify the actual workload reductions associated with these upgrades?
I'll just take one real fast, if you guys don't mind, and then get your take as well. There's probably something to be said for IPM and scouting. If you're working under an improved spectral environment, so to speak, you're not spending as much time or energy trying to hunt for pests that might be an issue that you need to proactively mitigate, just because you have more visual clarity within a space. So from a lighting perspective, I could say that might be something that would be impactful. Outside of that, I think earlier on I said something about you can either, phase up or out. Well, if you've got cheap real estate, your retrofit might include things such as like mobile pallet benching. See if I can find a picture to put on my background here. So that might be a retrofit, a technological retrofit outside of both lighting and HVAC that would greatly reduce labor, and is the whole point. So if you're in San Francisco, you're not going to be going that way, right? You'll be going the other way. And so that's going to have a different impact in regards to labor. But, if you're in the middle of Florida, maybe this pallet system here for your greenhouse is a technological investment you could make to really reduce people and the amount you spend on them.
Yeah, and
Awesome.
I think if you have low light conditions and you have inappropriately sized dehumidification, you're going to be battling botrytis and powdery mildew. And you know that. So your preventative, IPM plan now gets expensive, right? It's 3 sprays a week. It's multiple hours. It's multiple employees. It's pesticide products that you actually burn through. And I think from a labor perspective, it does get really pricey. So reducing that's important. Also, on a side note, just spraying an IPM strategy, if you have to apply that in late stages of flower, you're going to compromise plant vitality, you're going to compromise yield, and you're certainly going to compromise the quality of that product, as is reflected in test results. So I think the labor hours are hugely important. Also, think about this, like if you're in the situation where you need to apply some dramatic IPM, let's call it sulfur, and you do it inappropriately or you do it late stages, you can torch a crop, you can ruin the final product. And
Absolutely.
that happens with poor training or a high turnover of employees and, working them too hard without the appropriate tools and training. The impacts can be significant to your product, to your bottom line, not just labor.
Right, Jesse, that's a great thing to mention. And also let's expand on that a little bit. You were talking about clarity and how they were running into IPM issues. Can you briefly explain the changes that they've observed at Clarity since optimizing the facility more?
Yeah, I think the initial change was in a flower room wondering whether or not they would get to the finish line and be able to sell the product versus how much yield are we going to get. And what that did was change the employee mentality. So instead of thinking I'm working at a failing facility and whatever I do doesn't work, like telling your kids to go spray down the driveway in a rainstorm, like, why does that make sense? Don't have me do this. And that was what happening. It was this uphill battle. It didn't matter how many applications they put forth. They weren't getting ahead of it because the conditions were so poor. So once the conditions changed, the labor costs went down. The price per pound wholesale went up by about $500 across the board annualized. The yields went up, but the employees and the staff there were much more in tune. They were now integrated. They really cared. They were excited about the health of the plant. They were excited about these new rooms. They were excited to learn. And all of a sudden that mentality just meant for a better team, better workflow, more in tune employees that came to work excited to work. And I think those are important factors when you see what happened at Clarity, because they're all on board now. Everyone's working to the same goal versus just being an employee at a facility that has problems that you can't fix. Now they feel like they're really getting ahead of it and part of a bigger movement.
Right, absolutely. No, that was a great explanation, Jesse. And kind of to elaborate on that one, what are some of the best options for airflow when dealing with double-tiered tables instead of racks within the tables having less mounting space?
Sure. I think, traditionally people think I'm just going to put an oscillating fan every 6 feet on the wall and hopefully that homogenizes the room and they don't have CFD modeling and whatnot. And we realize that those oscillating fans cause so much velocity stress on the outside of the canopy. They don't penetrate deep enough, and the velocity on those sides of the canopy cause stomatal closure. So they really do compromise your ability to yield. They slow the plant's metabolic rate. So for us, we prefer like a disconnected from the duct in rack airflow system that runs the entire length of the duct, that has the right velocities for the entire length of the room. So whether it's 100 feet or 20 feet, that we're still maintaining that appropriate velocity of 1 meter per second through the underneath of the canopy to break up the boundary layer and deliver that CO2. There's different in-rack airflow systems to work with, and I understand limitations. But I think it's really important to think about how you're going to deliver the air to the plants. We prefer a bottom-up technique, which sort of helps mitigate microclimates and break up that moist air down below. And there's top-down delivery in rack methodologies as well. I think you have to think about how much space you have and what your techniques are. But in a drain-to-waste system, we can just put an in-rack airflow that you see behind Rob in that little animation sort of on the rack and weave it in between plants if we need to, and still maintain those velocities and sort of negotiate the plant canopy as we go, versus sort of a rigid, hard approach to a piped duct or something like that.
Awesome, Jesse. Yeah, that was a great explanation of that too, and some great things to consider when moving from a single tier to a multi-tier level system. So I want to re-share my screen with y'all really quick. All right, so I want to thank you all big time for tuning in today. This wouldn't be possible without the participation of everyone interested in what we're talking about here. So the recording will be available next week. We're going to send out an email with the link where you will find the recording at. And here, as you see on the screen, you'll find the contact information to our two most amazing presenters today. Aaron from Fluence and Robbie from Inspire.
Jesse sees those emails.
So yeah, I would like to thank you guys for tuning in big time. I would also like to thank Clarity Gardens for their participation in the data and the trials and information about the retrofits. And we're stoked for them, and they're showing now. Some of you may know about our collective collaboration with Resource Innovation Institute. On their site, you can find best practices for lighting as well as HVACD, and you can leverage their new Power Score tool to evaluate your facility's potential, like I was discussing earlier. So with that, I would like to leave you all with a couple key takeaways. The first one is you need to talk with your manufacturer to determine the best path for your business and your cultivation goals. And you need to do this early on because that determines the route that you're both going to take moving forward. Number two, we see at Clarity that these changes directly tied to financial and cultivation performances. So knowing that every action you're going to be taking within your facility, what is that going to look like as far as a monetary goal, and is it aligning with what you're trying to achieve? And then the last one, there are phasing approaches here. Obviously, we know through retrofit, you often do not have the capital to make the change right away. Like Rob was saying, it's sometimes it's better to be investing in a phased change, because then you can understand what's happening moving from one grow type or one cultivation methodology to the next one. And so phasing is phasing properly and effectively is really essential in helping your business succeed and moving forward with your optimization. So with that, I would love to thank everybody involved in this presentation, everyone on the line joining in. Keep it real, stay safe out there.
Thank you, Casey. Thank you, buddy.
Yeah, absolutely. And everyone have a great rest of the day.
Thanks, guys.
Thanks, guys.
Take care.